is Thomasine Dolan, and I am the Materials Innovation Design Director for MII. And I'm going to give everybody just a few more seconds to get back to their desks or their standing desks or tables or couches, whatever. I also want to mention that while on break, I was wondering or hoping that people are using the expo booths that we have. You'll find a lot of the innovators have put some interesting videos and information up there. I think there are about 6 or more innovators who have put up some information there. It's really, really fascinating. You'll learn a lot, and you also get context for people. So please check that out. So, okay, so this is our innovator spotlights. And over the next 50 minutes, you're about to get a crash course from 3 innovators working on some of the most exciting and game-changing products in the world. Each guest will give a brief presentation, and then we'll have time for Q&A at the end. So I'm going to just start. And I'm really honored to introduce our first guest. His name is Dayong Chen. Hi, Dayong.
Hello.
So I'm just going to give a little brief background on you, Dayong, if you don't mind.
Sure.
Dayong is the Director of Innovation at von Holzhausen, and he's the inventor of Liquid Plant, which he's going to tell us about today. But with Liquid Plant, or I should say at von Holzhausen, Dayong has been focusing on creating plant-based formulas for sustainable top coats and leather alternatives. So top coats that can be used across a myriad of products as well as leather alternatives. Dayong is a polymer material scientist by training, and he obtained his PhD in polymer science and engineering from the University of Massachusetts Amherst and conducted his postdoctoral research at MIT. Did I get that right, Dayong?
Yes, thank you.
Good. Hey, feel free to add anything I missed. You have a lot of credentials. Please add on. Yeah. So okay. Welcome. Well, if you're ready, unless there's anything you'd like to say, we can get started with your presentation, and then we'll have a few minutes afterwards for questions.
Yes, great. I will start with this presentation. I hope you can see the slides now. So we are von Holzhausen. So we are a science-driven, research-backed materials innovation company, focusing on creating high-performance materials from plants to replace our leather and plastic. So our business actually is multi-pronged. We synthesize, engineer, and formulate the plant-based top coat and leather alternatives. We manufacture these materials at scale, and we supply these materials to our business partners and customers in the industry of fashion, footwear, and furniture. We also supply these materials to automotive OEMs and their first-tier suppliers for car interior applications. So the other side of our business is we also create wage brand finished goods. And these finished goods including really backpacks, handbags, shoes, computer cases. We sell this to our retail customers through different channels, but mainly through our own websites. I know also right now we are running a discount for MII attendees. If you visit our booth, you will find out the codes for that. So this year we launched Liquid Plant. We believe it's truly the first 100% plant-based high-performance top coat, and it's zero plastic. So this is a short video. I hope you can see. We call Liquid Plant in action. So what it is, we cure the liquid plant into a translucent thin film, and we are using our hand to stretch it, twist it. As you can see, the film is fairly flexible, and yet it is fairly tough. We can supply the liquid plant as a standalone solution to our business customers and partners. You can use it to coat your own substrate, or we can supply it as a composite material with our tether fabric backing. So by the way, our tether fabric backing is a fabric we engineered using agricultural waste. So we believe Liquid Plant is truly a full circular solution. So we start with 100% plant-based ingredients. Through great chemistry tools, we engineer them into reactive molecules. This allows us formulate it into a liquid formula, liquid top coat formula. You can apply to different substrates to cure them into durable customer materials and products. So at the end of these products, you can choose to recycle them, or unfortunately, that's many of the cases, this end up in a landfill environment. They will naturally actually biodegrade into the nutrition that feeds back to the plants. So you see it's really a full circular solution. And through this process, there is no really toxic ingredients being used, and there is no microplastics left. So when we say, we use plant-based materials, we actually need the top three plant-based raw materials we are using for creating this formula. So they are corn sugar, castor oil, flaxseed oil. So we choose these raw materials because they are really abundantly available. So this allows us to manage the cost of liquid plant. And also this allows us to have intrinsic really scalability to meet the customers' needs. We also choose this material because they are actually needs competing with the food source. So through again green chemistry and the formulation tools, we engineered it into a liquid plant top coat. This allows us to coat a variety of different substrates. This can be paper, wood, metal, and fabric, of course, and many of the audience here are interested in. Essentially, you can use it as a paint to coat so many different substrates. We are running a pilot program right now for liquid plant. We are partnering with like-minded companies to replace plastic with plants. So our goal is really qualify liquid plant for many different applications to replace petroleum-based top coats. We are working with big industry partners. We believe that's how we can make a truly meaningful impact. So we want together working with these partners to really create a sustainable future for all of us. So we are open to co-brand to further raise awareness of plant-based materials. So with that, I'll stop the presentation and be happy. I'm very happy to answer questions and have a discussion with you.
Thank you, Dayong. That's amazing. It really is amazing. And maybe because I did give you the audience a bit of a bio on your background, but when I first met you, one of the first things I learned about your background was you worked for a company that, and please correct me, I'm sure I'll say this wrong, you worked for a company that you developed paints, but not just any paints. These were paints that had to go on like aviation and spaceships and rockets. Is that correct?
Yes. So
right,
I was working in the aerospace industry for a couple of years to really create top coats for different aircraft applications.
Yeah. So I feel like that's a huge credibility factor that you were able to do this. And how long did it take you to come up with liquid plant to a place where it's viable, that you've tested it over and over and over again? I know I'm sure you're still evolving certain aspects of it, but how long have you been working on it?
I have been working for a little bit more than a year, but our company has worked on this for a couple of years, for I think at least like 3 years, 3+ years on this concept. Yeah.
So you came in for the slam dunk. Yeah.
Yeah. So it's great to really join force with many good minds in the company to create this. Material.
Yeah. And so the original goal, I suppose, of Vicky van Holzhausen, the founder, so she has a material, a next-gen leather material, and so she wanted to start this. I'm guessing she was looking for that perfect solution to replace polyurethane or to replace petrol. Is that correct?
Yes. Vicky, our founder, has really committed, from like from the very beginning of this creating this company to use plant-based raw materials to replace plastic and leather, because yes. So so it's let me say this, right? So Liquid Plant is our latest development. We already produce plant-based leather alternatives, and at scale we can, if it's needed, we can supply really larger quantity right now. I mean, we are working with automotive automotive OEMs and first-tier suppliers.
So an automotive, that's the toughest one, I'm sure, with their standards. Dayong, I have two really good questions I want to get to because this is a short session. This one is from Helen Zha, and her question is, are there certain standards, industry requirements, for the durability and other mechanical properties of these top coats?
I mean, yes, we are trying to really match our top coat, like physical property, mechanical property, to the best state of the art polyurethane top coat. So so with that being said, right, so the highest again, the standard we see is really automotive interior. So we are trying to test our materials, to sort of in accelerated abrasion test to simulate like a 10 years use for automotive. Right. So it's really challenging to achieve that, but that's really our target.
Right. No, it's I feel like this is the holy grail. I have a question from Ash K, and she wants to know, is it waterproof and breathable?
Yes, it's absolutely waterproof. Breathable, that's a good question. We haven't studied that yet. That I mean, for footwear, I think that's a critical aspects. We will be study that when we're ready.
Yeah, that might be for certain applications where that would be critical.
Yeah.
For others, it's not really that important to be breathable if it's for.
Yeah, exactly.
Yeah. I have a question from Carolina Martin. She asks, can this plant-based leather be used also in technical engineering applications, for instance, garments and personal protective equipment?
I think it's possible. It's truly possible. So the reason why, again, for the personal protection, right? So I think it needs the material to be robust. So the reason we created this material, and we're not release it right now to our customer. We're working on to increase the robustness, and this robustness in terms many cycles of belly flex, many cycles of abrasion. So many cycles or many hours of exposing to UV, and so we want to really make a robust material.
I'd love to get this one last question in before we have to say goodbye to Dayong, because I need to bring on our next innovator. But this is a really good question from Miriam. What type of polymer is Liquid Plant? Is it susceptible to hydrolysis?
That's a very good question. So we are engineering this material to be biodegradable. So it's, I mean, this is a little bit technical. It's mostly sort of polyester material. So they are suspect to some degree of hydrolysis. So it's really a balance. It's a balance of the durability in sort of hot humidity environment, and also allow it to biodegrade at the end of the life.
Okay. Thank you, Dan. Thank you so much. This is just fascinating, and we clearly could use a whole session talking to you about Liquid Plant. So before I bring on the next guest, thank you, Dan. I'll see you later. I also want to remind people to go to the expo booth, whether you want to go right now or, well, hopefully you'll wait for our next guest and go after that. So with that in mind, I'd like to introduce our next speaker, and her name is Chen Keane.
Hi, everyone.
Hi, Jen. So Jen is the co-founder and CEO of Modern Synthesis. And Jen, actually, would you mind just giving a brief bio about yourself and how you got to this place, and then also a little bit of information about Modern Synthesis before you begin your presentation?
Yeah, and actually, maybe it's worth bringing the presentation up because it gives, I find it does give context to the story.
Okay.
But hi, everyone. I'm Jen. I'm the co-founder and CEO of Modern Synthesis, and we're a London-based biomaterial company that's working with microbes to craft biomaterials that are circular by nature and customizable by design. And we believe that craft and innovation, which are intrinsically linked, are being ever shaped by biology and our increasing understanding of the natural world. Not only are we now inspired and can better understand the world around us, but we can actually work with the living systems that the earth provides to actually create new types of materials and reimagine the products that we use every day. So I come from this materials world. I've worked in the fashion industry most of my career, mostly with Adidas in sportswear. And this was about sort of 5 or 6 years ago now, where we realized that all the materials that we make today, or that we wear, most of them are based in synthetics. And there really weren't good solutions a few years ago. And Dayong gave an intro to some of the technologies that are now coming out. But this shoe I actually grew in 2018 as part of my MA project at Central St. Martin's, where I was introduced to scientists from Imperial College who were looking at microbes as sort of micro factories to create new types of natural materials. And I was inspired by the performance of these materials to grow the shoe to show how these materials could help us not only displace incumbent materials that we use today, but can help us design and create in completely new ways. So talking a little bit more about microbes and what we do here. So this is bacterial nanocellulose, and it's a bacteria that's called K. radicus. And it was actually isolated and sequenced by my co-founder, Ben, almost a decade ago. And it's a really interesting bug, mostly because it's incredibly efficient. So it produces a lot of this material with very little resources, but it also produces a very interesting fiber called nanocellulose. And we see this as the next noble fiber for a few reasons. So first of all, cellulose is nature's most versatile building block. It's in cotton, it's in wood, it's in pretty much everything around us today. Nanocellulose is the strongest and finest form of cellulose. And these bacteria produce it at this really fine and pure scale that makes these really strong fibers. They're 8 times stronger than steel, stiffer than Kevlar, and they have a myriad of properties also in how they bind to each other to create these really strong structures. Taking inspiration from that with my background in textiles, actually developed the precursor to our now whole suite of technologies that really are built around combining these fibers together with textile technologies. So this is a combination of biofilm and textile. And as you see here, it acts a little bit like how rebar reinforces concrete. So you have that core stability that's reinforced by the biofilm. And this allows us to, it won't let me, sorry. Seems to be stuck. There we go. To create really a whole new class of textiles that are pushing the boundaries of natural materials. And when I say new class of textiles, I really mean this new discipline. And it's like knitting or weaving in that we're able to make not just one material, but really it's a whole platform that enables multiple different material technologies where we're able to sort of reinvent these new classes of materials for the products that we use. Here in our micro factory that you can see behind me, we've been doing the work to really take that process and look at how it can scale. And so we've been able to break up that process into multiple steps that allows us actually now to utilize existing machinery capacity. We've recently, which is news that we haven't shared yet, been able to enable roll-to-roll production, which means we can actually feed into existing textile infrastructure and supply chains to create a material that can help reduce emissions as up to 65% less without plastics, but also precision biomaterials that can offer designers and brands infinite creative possibilities. And this is new forms, so new material properties, new feels, and new functions. As I mentioned, we recently opened our London microfactory where we're able to do every step of that process here in-house and really tailor these materials to the needs of the partners that we work with. And here we're working with brands and their manufacturers, which is often overlooked, to tailor these materials for the product applications. We've now got a team of 20 of scientists and engineers who are razor focused on hitting industry standards, as well as working with manufacturers to de-risk scale up over the coming years. We're planning to launch first in fashion accessories, We're already starting as well to look at footwear applications in automotive, as well as new markets that are enabled by the intrinsic capability of nanocellulose to have interesting properties, so such as electronics and other applications, which is enabled even further from sort of the biological aspects of the material. So all of these materials I've talked about is a natural base material. It's produced naturally by this organism and then processed through our technology. Here in-house, we also have the capabilities in future to be able to work with these to actually engineer these organisms to produce other things. So here's an example we did with Imperial College, where we've actually grown in the color. So we can combine steps and minimize wastage through that process. I was hoping to have images today because we actually just got a delivery of some of the products that we've been working on with partners. But make sure you stop by our booth at Future Fabrics Expo if you're in London next week to see the latest on our materials and learn more about what's coming up.
Chen, that was amazing. Thank you. There's so much information in there. I needed everything to slow down. I think I need to print it out, actually. So there's so many things I want to ask you from those last few slides, but I want to back up a little bit. So when you started, what were you trying to mimic a current material we have out there?
So that's a really good question and something that we get asked a lot because I think the easy answer is, okay, we've got leather, we've got these materials that have this cultural understanding. Yeah. It's easier to sort of drop in because that's what the customers understand. And I think actually from a design background myself, I think that's a mistake. I think there's an opportunity now with these materials to actually build new understandings and new cultural heritage through these new technologies. And that's something that we're really trying to drive. So we can mimic the properties of leather, we can mimic the properties of synthetics, and we can actually create a whole range of materials. And I can actually hold up some that are more sort of like synthetic based looking. We can do more thicknesses that are more similar to a leather. We can do all sorts of textures. But I think it really comes down to what the designers can imagine. And this is where we're looking to support our partners in really reimagining their products.
Yeah. Have you had a lot of interest from brands across those different industries that you mentioned before, like fashion, home, auto?
Definitely. I mean, I think other founders in our space will acknowledge, like, we have more demand than we can handle, and it's really about focus. And so what we've been looking for and the partners that we're working with now are really true partners for the long run, and they understand the R&D and are working with us together to get these materials to market. And it's really, like I said, it's a true partnership that we're looking for at this stage. And we're booked out through the next year, but we're already starting to plan capacities for next year as we're growing our sample production as well as moving to scale. So definitely reach out if we haven't connected yet.
So can you just tell us briefly about the benefits of a co-development partnership? I understand the benefits for you, but there's also benefits that go both ways, I would imagine, because they're getting early input and influence into a material based on their needs, but perhaps you can shed light on something else too.
Yeah, definitely. So the benefit of working at this stage is really being able to sort of design from that nanoscale. From the organism level, designers now have the possibility to control their products and really design it from a stage that we didn't have access to decades ago. I think also from a capacity standpoint, like we're growing quickly and we've now to scale quickly, but in 5 years' time, there's going to be a limitation on how much access these brands can actually have to these materials. And so by working with us now, we're actually partnering to make sure that we can actually get those to market together with these partners, and they'll be the first.
Okay, amazing. So just two more questions because we'll be out of time soon. One is, and I bring this up because our previous discussion this morning was about LCAs. And one of the panelists said the sooner you start LCAs, the better. And I was wondering if that was part of your process.
Definitely. So we've done a preliminary assessment, which is where that data came from the presentation. But this is something that we've roadmapped this year to actually plan out, not just for like huge scale, but looking at what every step of the way looks like and being as transparent with that as possible, because an LCA is really dependent on where you're producing the inputs locally, especially with micro produced materials. It's the feedstocks locally, it's the energy supply. So it's really about mapping out that trajectory and being as transparent as we can over the coming years.
there's actually one other little question I want to ask you. I forgot about feedstock. So like, because you're not fully scaled yet, so your feedstocks are locally. Is that something that you've planned for as you grow?
Yes.
Using local or regional?
The advantage to this organism is that it's feedstock agnostic, which basically means we can use waste feedstocks, pretty much any feedstock, any sugar source that's available. So in the initial, it's about what is available and what we can use off the shelf quickly to be able to scale fast. But we've done really interesting trials about waste streams, such as sort of cider production in the UK, or other agricultural waste streams that we can tap into near our production sites that we can capitalize on to maximize our impact.
Okay. Thank you. There was like 6 other questions I didn't get to. So anyway, I welcome and I encourage everyone to visit Jen at Modern Synthesis, go to the expo booth, and good luck with the fair you're going to, the future expo fair.
Thanks so much.
Thank you, Jen. Bye.
Bye.
Great. That was cool. So my next guest that I want to bring to the stage is the marketing officer, the chief marketing officer for Ecovative. And I'd like to bring Andy Bass to the stage, please. Hi, Andy.
Hi, everyone.
Good to see you. Thanks for joining us. So just for a little background to our audience, Andy just got in here by the skin of the teeth, as they say, just landing at the airport in London about a few minutes ago, I think. So
that's right. I made it, but my clothes didn't. So we'll hope they arrive tomorrow.
So Andy, Andy, I would love if you just give a little brief intro about yourself, because we want to get to the video you made, but a little intro about your background and of course about Ecovative, and then Andy will show us a beautiful video that they've made.
Yeah, so briefly, my background, I'm a molecular biologist by training, but my creative genes started expressing themselves somewhere along the way. And I kind of merged into a bit of an artist as well. And where I found my sweet spot is really, my passion has been telling all the cool things that are happening in life sciences through a story that the consumers can relate to and sort of get behind and understand. And so that's sort of where I sit in my career and what excites me. And with Ecovative, we use mycelium, which is the root structure of mushrooms, and are really looking across multiple large verticals in the consumer markets, from packaging to whole cut plant-based meats and materials, where we're focused on leather-like materials and elastomeric foams. And so you'll see a lot more in the video. And I pre-recorded the audio because I wasn't sure if my flight would be delayed. So this is going to be a first peek that any general audience has ever seen of our farm. We've shown just animation up until this point. So I'm really excited to debut a little bit more of an inside look of Ecovative here in the video. We work with mushrooms, more specifically the mycelium they grow from, to make new foods, materials, and other planet-friendly products. We've engineered processes to bring mycelium from the forest into vertical farms to grow at massive scale for consumer goods. Up until now, this animation is all that we've revealed of our process, but today, I'm going to give you a first inside look at the world's largest mycelium farm. In nature and in our farms, mycelium grows through wood chips, hemp stalks, and other organic materials. Our process starts with these raw ingredients stored in giant silos near Ecovative's headquarters in Green Island, New York. The raw materials are heat sterilized and mixed together with our specialized mushroom strains to grow 100% pure mycelium for our Forager Hides and Foams brand. Once inoculated, the material is carried by conveyors to be weighed, separated, bagged, and sealed. What we're seeing here are slower test speeds for what will be a much faster process. This is a full-scale farm, and at full-scale operation, it will produce about 3 million pounds of mycelium every year. The bags are stacked by our very cool robots, all the while the mycelium is actively growing in preparation for the next stage. Our raw materials plant and mycelium farm operate with a series of automated processes that are specific to Ecovative's production methods. This debagger prepares the substrate for incorporation into the farm. All throughout this process, we're making sure that nothing contaminates the substrate. As you can see, there's a lot of material, and the equipment for distributing it evenly throughout this system of vertical farms can be complex, to say the very least. In some ways, this is very reminiscent of modern mushroom farms, even though what we're growing is mycelium, the root structure of the mushrooms. Our technology is engineered not to grow mushrooms, but the process can be integrated into existing mushroom farms, which creates opportunities to quickly scale up production all around the world. Our farms create large format sheets of mycelium, 4 feet wide by 85 feet long, ready to be used for a variety of applications from footwear to soft goods and upholstery. Efficiency is the name of the game, and it's an impressive experience to walk through one of these massive grow rooms. These farms can be constructed in pretty much any environment, so our mycelium materials can be grown close to the manufacturers or the customers that use them. Depending on the application, the mycelium grows for around 9 days. It's a farm, and it's also a factory of sorts, where most of the energy for the final product comes from the mycelium itself. This saves an immense amount of resources. We can produce miles of this material in facilities like these, and all the mycelium requires is that we feed it plant-based waste and create the proper conditions for it to thrive. At this point, the pure mycelium is separated and then prepared to be processed into its final form. In the case of forager hides and foams, we harvest the sheets, slice the mycelium, and ship to our tannery partners, such as Eco Leather, who turn the raw mycelium into beautiful textiles that can be used for footwear, accessories, and upholstery. One of our recent collaborators is Myers-Manx, a dune buggy company in California. They use our forager material to create these beautiful car seats. The process that led from raw material to this finished product is so much shorter, cleaner, and better for the planet than an animal-based alternative. And the results speak for themselves. We've mastered the process of growing mycelium, and we rely on the insights of our partners and collaborators to discover their full possibilities. We're just getting started, and the possibilities are already inspiring. Thanks for watching.
Well, that was beautiful. Thank you, Andy.
Yeah, thank you.
So I have so many questions. I'll of course, I want to lead with the Manx, but I'm going to end with the Manx because I have questions about that. I want to go back to, so just sort of like summation, there's so many things that we heard in there, that vertical farms, which is, looks like I'm frozen. Can you hear me?
Yeah, I see.
Okay, well, as long as you can hear me, then I'll just keep going. Sorry about the image. Okay, looks like I'm back. Okay, so we heard about vertical farms, wood chips, hemp stalks in silos, really tall silos, very farm-like, using mushroom strains, and 3 million pounds of mycelium each year. That's where you are now, or that's where you'll be next year?
The farm is set up for 3 million pounds right now. We haven't validated every room in the farm yet. So they're being turned on weekly at this point. And so I don't know the exact date, but we will be fully online this year.
Okay. And then that image of the mycelium sheets, like the 4 feet by 85 feet, that's nuts. That's completely insane. It looks like it goes on forever. And then you have a 9-day growing period, right?
That's right. Yeah. Depending on the strain and the application we're growing for, like it's the mycelium can grow anywhere from 6 days to 14 days, but 9 is sort of the sweet spot for textiles that we're talking about today.
Okay. And then you mentioned in the video about the proper conditions. So can you tell us what the proper conditions are? I'm assuming that has to do with like temperature and humidity.
Yeah, that's part of it. They don't tell me everything because they know I like to talk. So it's they keep that in the vault. But it really, a lot of it is the substrate that we start with. So having the right blend of nutrients for the mycelium to grow with. And then you're right, controlling the environmental conditions so that the mycelium is sensing that it's still underground. And
Okay.
if we give it the signals that it's coming above ground, then it starts to make a fruiting body and become a mushroom. And we don't want that. We want consistent homogeneous tissue. And so by controlling temperature, humidity, and other factors, we get just this network of fibers that grow together and up into the material that you saw in the video.
Okay. I wanted to ask you about the Eco Leather collaboration. So that's really fascinating, but also it touches on a session we had yesterday, or maybe it was the first day, about diversification of businesses. So Eco Leather being a really old tannery out in the world. It's been around forever. Everybody knows about it if you're in the business. And so for them to take you on, did you hunt them down or did they seek you out? How did that work? Like to find them as a partner?
Yeah, so I think it was sort of, I think, mutual. So Echo is looking at a lot of different types of materials that could be textiles.
Mm-hmm.
They have some customers that they don't want plastic material. They may not want animal-based material. So what's a medium that can fit there? And so mycelium was one that rose to the top, and they had actually kicked the tires on a lot of different sort of mycelium technologies.
Mm-hmm.
And came to us. And by the same token, we had also spoken to a lot of other tanneries and a lot of other sort of finishers. And we getting to know the field, like we sort of came together and had a similar mindset. Like Echo is one of the most innovative, sustainable tanneries that I've seen. And they sort of fit our ethos and how we want to push the material out into the world, and not just, coat it with petroleum-based materials and that's going to cause issues at end of life. Like they really want to, they see the material as purpose built. Does it need to last 100 years? Maybe not. Does it need to last a couple years? Is it like a case that you're going to use and your technology is going to evolve in a year from now? If that's the case, we want it to degrade, be a nutrient to the earth, not sticking around as a pollutant. And so just those mindsets really aligned, and it's been a fabulous partnership thus far.
I'll bet the learning is like off the wall. So tell me about the tanning process if you can. So the finishing of it, basically the finishing of the mycelium. So it's applying color and finish and protection and textures, etc. So that's all done with green chemistry, or what? How does that fit into sustainability?
Yeah, so that's really the focus. Is ultimately Echo serves brands. So we're providing mycelium. At our step, mycelium is fully home compostable, so it degrades or it's circular back into the earth within 45 days. When the brand requests from Echo, depending on what the end product is, they have a different suite of chemistries that they can choose from.
Okay.
We've been working with them to develop bio-based chemistries to be align with our goals as much as possible. But one of the things I can say is that they completed a biodegradability study or disintegration test, which found that the finished textile actually biodegrades in 60 to 90 days, depending on which chemistry is used. And so it's also reasonable, I think, to assume that we could reclaim any sort of scrap material as a substrate to basically feed back into our process. And one of the things we've demonstrated is that the particular strain of mycelium we're using for textiles can actually remediate pesticides that are commonly found in agricultural waste. And so pesticides, like most dyes, are aromatics. So it's not unreasonable to think that we could just basically make this a fully circular loop for any scrap materials that come out of their finishing process too.
I'm so glad you brought that up, because that was one of my questions about waste. Because it's, before I get to the Echo part at the factory level, but starting within your own factory, is there waste? I'm not sure what that waste would be, because it looks like it all goes into just making the mycelium itself.
Yeah, so most of our process produces compost and clean water. And that compost can either go towards growing more crops, or we've also looked into animal feed, and actually even going back into like the mushroom industry as a substrate to grow mushrooms. And so we from our process, the waste isn't significant.
Mhm. I have a question from someone in the audience named Juliana, and she's asking about the final product after it goes through Ecoleather's process. Is the material having any reaction to the natural environment, for instance, becoming dry and cracking? Which is a good question because I've seen some innovations that they do become that. It's like the hydrophilic.
Yeah, I don't know specifically things to point to answer your question. I think it does depend on how so we've done a lot of the standard tests, abrasion testing and wear testing and things like that. And I think we see different results with different chemistries. And so using that information, we really, again, want to sort of dial in, okay, what's the application that we're building this for? And can we go down this route with chemistry with the brands? And so, yeah, ultimately, we want to behave like materials that brands are using today. We want to fit into the marketplace now. And so, sorry, I don't have a better specific answer for you, but that's sort of the way we think about things.
Yeah, no, that's true. I think we all forget that brands really call the shots on the final product of what it needs to be able to do and the metrics that it needs to meet. I wanted to ask you about the feedstocks and where that comes from and where, yeah.
Yeah, so we've validated now for all of our mycelium different processes over about 700 different plant-based ag inputs. And so what that means is we're sort of not beholden to a supply chain of a certain crop. We can be quite diverse, and also that means we can set up farms or grow our process pretty much anywhere in the world with this diversity of feedstocks. We try to source within sort of 100 or a couple hundred mile or kilometer radius from where we're actually growing the mycelium. And we're doing that in upstate New York, where the farm that you just saw in the video is. And then also we purchased a raw material company in the Netherlands, and we're doing the same thing there. They're actually right down the road from Echo.
Right. Is that one of we had another conversation yesterday with some panelists about scaling and the challenges of scaling. And I would love to ask you this, because you're there now. You're not kind of there, you are there now. And what were some of the biggest speed bumps or hurdles in scaling, like finding a supply chain for ag waste, or, growing vertical farms doesn't really, well, so there are some vertical farms for certain agricultural products. So I guess maybe there were some you could lean in on that a little bit, but I'd love to hear.
Yeah, I mean, we've definitely had our growing pains, and it's really hard to go from a small scale experiment up to what we're doing today. We've today are basically the largest raw material producer of substrate for mycelium or mushroom farms. And so we had to solve that problem, that scale up problem, by just buying and developing our own facilities to make the raw substrate. You saw some of that in the video there. So it's definitely the other thing I think that's really important for companies that are starting out is try to use things that are off the shelf. Don't make bespoke equipment if you can help it, because it's costly. You want to be able to move quickly and not spend too much money on one specific piece of equipment that you have to design yourself.
Something else that came up in our conference this go around was about labeling. So your material, what's the recommended label or hang tag for this sort of product for material? Is it mycelium or?
Yeah, so it's we'll actually brand it more consumer facing than that. So it'll be a brand. The first iteration you'll see is Forager is our brand for the mycelium materials for textiles and foams. But then we also are partnering with Echo to do a lot of that finishing work. And so you'll see messaging that sort of incorporates both of our technologies and both of our brands when these products come to market.
Okay, yeah, it's interesting for me because I think of customs and shipping, and when as this stuff starts crisscrossing the world and the regulations involved, and what are we calling it? How are we labeling it? So
Right. Yeah. For customs, we just have to be as generic as possible to make sure it doesn't get held up. Once it gets finished into a textile, then I think you can just label it as such, a textile. It doesn't necessarily need to be down to exactly what the
Okay.
molecular form of it is.
Okay, so we've run out of time, Andy, but I wanted to, if there's anything you want to leave us with in terms of like partnerships or availability, you're being commercial. I know actually you mentioned something before we got started about the partners that you have now. I don't know if you can name them, but I know that you've got a lot going on.
Yeah, we do. So bestseller, Wolverine, PVH. There's a long list on forager.bio of the companies we're working with that's publicly released. And you'll see more from us coming out early next year as far as products that you'll be able to buy. Okay. Yeah, please reach out if you think that this material would work in your product line, and we're happy to have conversations. We're developing a queue now and have sold out of material through 2024 at this point.
Wow. Okay. Thank you, Andy. That was amazing. Thank you very, very much. And yeah, great job. Thanks. Safe travels. Okay, everyone. Thank you. So that finishes our crash course of innovators for today. And I just want to remind everyone again to please visit the expo booths to check out some of these innovators where you get more time to really examine things and ask questions and make contacts. And then we're going to have a 10-minute break right now. So we'll see you at the next panel. Thank you.